anatomists and physiologists. This is part 4 of our reproductive series. We're talking about female reproductive physiology. This slide has a lot going on with it, but stay with me. The gonads of female reproductive physiology are the ovaries, and this is where gametes are produced. Those gametes are egg cells or oocytes. This process is still meiosis, but in this case, it's called oogenesis. So, oogenesis. It's spelled like oogenesis, but it's oogenesis. That's egg formation. It's still meiosis, but it happens a little bit differently than we learned in spermatogenesis. A little bit different. The stem cells, though, we still have stem cells as we talked about in males, but instead of spermatogonium, we have oogonium. So I'll highlight that in pink. Oogonium. Those are our stem cells, and then the plural of oogonium is oogonia. Oogonia divide into primary oocytes. So that becomes primary oocytes, which are the cells that will become eggs eventually. But the interesting thing is that primary oocytes will begin that process of meiosis, but it will arrest or it'll pause during the end of like prophase 1. The end of prophase 1. And this all occurs, I'm zooming out to show you this panel here. This all happens, the formation of the primary oocyte and the arrest of meiosis begins before birth, like in utero. All of the primary oocytes pause at prophase 1. And they just get put on pause until they're needed. And when they're needed, we'll talk about it. Once those cells are needed, that primary oocyte continues on with the process of meiosis and will continue on with that process of meiosis until meiosis completes itself. Meiosis 1 will then be completed until meiosis 2 starts. Meiosis 2 will start, but then will arrest again. So that's primary oocyte will become a secondary oocyte, but that secondary oocyte will be arrested, paused, in metaphase 2. And metaphase 2 will pause, and the oocyte will just kind of hang out like this until or if it's fertilized. Only if it's fertilized will then the oocyte finish process of meiosis 2. We're going to come back to this. Throughout the process of oogenesis, the oocyte is surrounded by cells. Those cells surrounding the oocytes are called follicles. And those surrounding cells, they have a special name. They're called granulocytes. And there's different names for different follicles depending on how much there is going on. So the primordial follicle, that word primordial means like primitive, because it's really early in development, right? So primordial follicles will then develop along with the primary oocyte into a primary follicle. And a primary follicle will become a secondary follicle. And a secondary follicle will start adding more and more layers of cells around this primary oocyte. And then secondary follicles will become vesicular or antral follicles. And that word antral refers to antrum, which is kind of like this fluid situation here. That kind of blank part where we have egg there, layer of cells, and then we have the antrum. And inside of here in this cell, this oocyte is a secondary oocyte. Not all follicles will be ovulated. Many of the follicles and the oocytes then will undergo apoptosis in this process called atresia. So I'm going to write this to the side. Not all follicles are ovulated, like released into the uterine tube, right? If they're not ovulated, then they undergo this process called atresia, which is just cell death. Those eggs that are ovulated, though, they become ovulated because they get recruited under the influence of hormone activity. Overall, only about 500 oocytes or less are ovulated over the course of life. Meiosis looks kind of funny in oogenesis. Do you remember in spermatogenesis we had our spermatogonium and then eventually 4 sperm cells? However, when we look at meiosis of oogenesis, we have one oogonium produces one ovum, one egg cell. The reason for this, like where everything goes, is that there's really unequal divisions of cytoplasm. So I'm going to zoom in. We have our primary oocytes, and our primary oocytes, upon the completion of meiosis 1, produce a secondary oocyte and this like little bit of a cell called a polar body. A polar body still has all of the chromosomes that we would expect in a normal meiosis, but it just doesn't have that much cytoplasm. That polar body will then divide just like how we would expect it to, but that secondary oocyte, the big honkin' one with lots of cytoplasm, will then divide again as meiosis 2 is completed, again, only upon fertilization, right? And that will make our mature ovum, but it'll also make another polar body. These polar bodies have really, really wimpy cytoplasms. Since they don't have that much cytoplasm, they can't really sustain themselves to do all the things they need to do. So the polar bodies eventually degenerate. So the polar bodies will degenerate because they just don't have the resources they need. However, that ovum, that oocyte, that's the thing that will persist. Okay, again, lots going on this slide. Stay with me. There are several stages of follicle development, so that's what we're talking about here. So what I want to point out to you is that we're showing you the same thing, but in the middle, like this picture, that's the cartoon. And then everything around it are all like histology pictures. I'm going to stick to the cartoon. A follicle is just a group of cells that surround a developing oocyte. There's primary oocytes, which are doing meiosis 1. Remember, meiosis 1 starts before birth, gets halted at prophase 1 for a long time until it's recruited as a potential follicle to be ovulated. Okay, so the first thing that happens, let's see, where is step 1 here? The first thing that happens is we have primordial follicles. Those primordial follicles are the most primitive ones, and they're where follicles spend most of their time. They're just waiting on being recruited. Primary follicles, they're a bit more mature. So notice we get a little bit bigger, a little bit more mature, but then also you start to get this little like layer around the outside of the oocyte. That layer that's around the outside of the oocyte is called the zona pellucida. The zona pellucida means clear layer or clear zone. The primary follicle will become a secondary follicle, so things get bigger, there's more cells, or bigger, more cells surrounding. Those cells around it are called granulosa cells. Cells, like these cells, are called granulosa cells. And all these cells do is just like support the oocyte's development. Lots of growth of the oocyte is happening here in that follicle. Eventually, we start to get this thing called theca folliculi, and that helps form into the antral follicle or helps form the antrum. So remember the antrum is that little space there. The theca folliculi, they help with developing that antrum, that antral follicle. That helps form the fluid-filled cavity called the antrum. So, okay, so once we're here, there's a secondary oocyte in there. And then it's halted there. We're halted in here at metaphase 2. Hormone activity will guide its further development. And when those granulosa cells get to be thick enough, they get a special name. Those cells on the outside are called corona radiata. So those cells there on the outside are corona radiata. And that's what hangs out um, around that oocyte as it's released in ovulation. And notice that the rest of that follicle just gets left behind. So egg cell inside, we have that zona pellucida around the outside, and then the corona radiata at the outermost level. The leftover cells and stuff of that follicle become this structure called corpus luteum. Corpus luteum. The corpus luteum has some endocrine function that we'll talk about. But then that corpus luteum will eventually kind of like degrade into a little bit of scar tissue called corpus albicans. Albicans means white. And that corpus luteum, if pregnancy does not occur, becomes the corpus albicans. Again, we'll talk about it. So, what's guiding all of this? What's guiding ovulation? And ovulation can be described as a cycle. Our text says it's two phases. I argue it's three-ish. Okay. Um, First phase of the ovulation cycle is the follicular phase. This is day like 1 to 14-ish. Okay, because the ovulation cycle is about 28 days long. For each person, this is different. It can be a little bit shorter, a little bit longer, but on average, 28 days. Okay, so the follicular phase that occurs first as those vesicular follicles grow. And this is largely under the influence of the hormone FSH from the anterior pituitary, right? And the vesicular follicle that's most sensitive to FSH is usually the one that's ovulated. That's called the dominant follicle. So, follicle that is most sensitive to FSH, that's called the dominant follicle. That's the winner. That dominant follicle is the one that wins the opportunity to be ovulated. that dominant follicle will cause the oocyte within that follicle to complete meiosis 1, become a secondary oocyte, begin meiosis 2, and then eventually be ovulated, which is the middle part of the cycle. So we have the follicular phase, ovulation, and then the luteal phase. So ovulation is when the oocyte from dominant follicle is released to uterine tube. After ovulation is the luteal phase. So the oocyte with its corona radiata are gone, but the rest of the follicle in the ovary is still there. So it becomes this thing called the corpus luteum. So leftover bits of dominant follicle becomes the corpus luteum. Interestingly, the corpus luteum makes progesterone and estrogens. But the corpus luteum degenerates if the egg is not fertilized. So if egg not fertilized, the corpus luteum degenerates into the corpus albicans. That's just like a scar. Leftover bits that we're not using. And that just kind of hangs out in the ovary, right? However, if pregnancy occurs, the corpus luteum does a lot of that initial hormonal like heavy lifting until that placenta is in place. So the corpus luteum, big role in hormone stuff if pregnancy occurs, especially in the early days. Like male reproductive physiology, female reproductive physiology is driven by hormones and driven by the HPG axis, right? So remember that the hypothalamus still releases that GnRH guy, and then from GnRH, we'll talk to the anterior pituitary and still release FSH and LH. It's the same story as before. We're still going to act on the gonads, in this case, the ovaries. When FSH and LH act on the ovaries, this is going to result in estrogens and progesterone. FSH acts on the follicles, on those vesicular follicles, specifically on the cells surrounding that oocyte, on the granulosa cells. LH tends to act on those thecal cells. Remember that this will recruit a few follicles to avoid apoptosis. Remember that apoptosis is called atresia, right, during the ovarian cycle. So we get recruited to have a shot to be ovulated. And then the follicle that wins, that's most sensitive to FSH, that wins the opportunity to be ovulated, the dominant follicle. And once that dominant follicle is selected, that follicle will grow and mature and prepare for ovulation. And that produces lots of estrogens. So that's all what happens during the follicular phase. And then that egg is then ovulated, right? The corpus luteum starts to be formed after ovulation. In the follicular phase, notice the luteal phase, referring to corpus luteum, this is when LH is really in charge. It's called the LH surge because there's lots and lots of LH. LH stands for luteinizing hormone, like the luteal phase, like the corpus luteum. So LH is in charge of forming that corpus luteum, which then makes progesterone and estrogens. And then if pregnancy does not occur, LH levels, they kind of like dwindle off. And then that corpus luteum just becomes that corpus albicans, that scar tissue. So that's the ovarian cycle. What happens inside the ovary, leading to ovulation and then thereafter. However, there's also events that happen inside the uterus. That's called the uterine cycle or the menstrual cycle. The ovarian cycle is a focus on the ovaries. The menstrual cycle is a focus on the events of the uterus. Specifically, what's going on here is not just the uterus, it's really the endometrium. That's that innermost layer of the uterus. So if we were to talk about the uterus, here, I have a picture right here. So let's talk about the uterus. The innermost layer of the uterus is called the endometrium. Then we have that myometrium and then the perimetrium there on the outside. So we're talking about the lining, the endometrium. We have to remember that the endometrium consists of two layers. We have the basal layer, and we also have the functional layer. The functional layer is the one that can get shed during the process of menstruation, and that's what happens during the menstrual phase. So it's a shedding of the functional layer of the endometrium. So the menstrual layer, or the menstrual phase rather, that's what we're talking about first. The menstrual phase involves this functional layer just going away. Typically lasts between 3 to 5 days. And it's also associated with an uptick in estrogens from developing ovarian follicles. The next phase is called the proliferative phase or the pre-ovulatory phase. And I remember this because pre means before. So everything that happens before ovulation. What happens before ovulation is that we build up that functional layer again. So that functional layer in the pre-ovulatory phase or the proliferative phase gets built back up. Build functional layer. And the functional layer has some really important characteristics by being supervascularized. It's supervascularized by spiral arteries. Lots and lots of blood vessels. There's also lots of progesterone receptors here, and lots of estrogens are being released. This causes cervical mucus, thins. It's less viscous. This is more ideal for sperm to enter the uterus through the cervix. And then the end of this phase is ovulation. So that cervical mucus thins as a result of estrogen. The next thing that happens is then, well, okay, so in this is in the uterus, but at the end of this proliferative phase in the uterus, we ovulate an egg in the ovarian cycle. So this leads us to the post-ovulatory phase or the secondary phase. This happens after ovulation. After ovulation. This is prep for implantation. For implantation. Implantation of a fertilized egg, right? There's a lot of progesterone from the corpus luteum that's being released from the ovary. So lots of progesterone. Released from ovaries. corpus luteum. And that functional layer is making lots and lots of nutrients and releasing them into the uterus. So lots of nutrients from functional layer. And that's because we're trying to be able to support that potentially fertilized egg as it arrives. The other thing that happens is that the cervical mucus will thicken again. And this is to block entry and exit of stuff from the uterus because if implantation in pregnancy occurs, we want to be prepared. However, if implantation doesn't occur, those LH levels die off, corpus luteum becomes non-functional, and then progesterone levels, they also fall. As progesterone levels fall, LH levels fall, that means the functional layer will start to kind of be sloughed off, and that will bring us back to the menstrual phase, if not fertilized. So we're going to look at a lot of graphs to show you kind of how all of the things work. This slide is showing you how the levels of LH and FSH vary throughout the uterine cycle. Remember that between, so we have like this, all this like medium blue is the proliferative phase, and then the secretory phase is everything in green, menstrual is everything in the light blue. So as those levels of LH fall off, that's when the menstrual cycle picks back up. Remember that between that proliferative phase and the secretory phase is that process of ovulation, where the egg is released. This next graph is showing you what happens during the ovarian cycle. So ovarian cycle. So notice we have those phases down below. We have the follicular phase, the ovulation, and then the luteal phase. I really like the pictures here, is why I'm showing you this graph. Note that ovulation occurs right in the middle. Again, we have those uterine phases there. And the luteal phase is showing you the presence of the corpus luteum. If that egg isn't fertilized, that corpus luteum degenerates. And then it'll become the corpus albicans, and then notice that that will result in the menstrual phase. This graph is showing you the hormone levels of estrogens in orange and progesterone in green. Notice that estrogens are the driving force in the proliferative phase of the uterine cycle, which is the building up of that functional layer, and it peaks right before ovulation. Progesterone rises and falls during the secretory phase, and that's when the functional layer is really preparing for implantation. So functional layer, prep for implantation. That's what happens during the secretory phase. If implantation doesn't occur, though, then that progesterone level will start to fall. If progesterone levels fall as a result of the loss of the corpus luteum, then that functional layer starts to be lost, and then the menstrual phase will begin again. And I always remember that progesterone is in charge of the secretory phase because it's like preparing for implantation, right? Preparing for pregnancy. So I think of progesterone as like progestation, pro-pregnancy, prepping for pregnancy. That's what progesterone's all about. Okay, lastly this is the endometrium, that layer, that basal layer in that functional layer. So basal layer at the bottom, functional layer there at the top. And notice how richly innervated that functional layer becomes. So notice that during the menstrual flow, we start to lose that functional layer. We build it back up. In the secretory phase, we really prepare for implantation, but if implantation doesn't occur, then menstruation begins. This is all of the graphs I just showed you, but like all on the same slide. So the thing to remember here is that I think it's just important to know that the ovarian cycle and the menstrual cycle, they're happening in two separate things because it's like separate organs, the ovaries, the uterus. But they're really operating together because the common goal is to prepare the egg for fertilization and for that fertilized egg to be implanted. But if fertilization doesn't occur, then implantation doesn't occur, then menstruation occurs. So it's all related, is what I'm trying to tell you. The last bit that I have here, I know this text is small, but I know you have the slides on your own, is that estrogens, progesterone, testosterone, they do lots of stuff. I'm adding this table from our textbook because I think it's really good to take a look at when you get the chance. And we have to remember that sex hormones, yes, they act on the reproductive systems, but they also involve lots of secondary sex characteristics and other stuff. So in females, it looks like this. So estrogens and progesterone, they do a lot of like secondary sex characteristics. And this includes things like breast development. That includes things like subcutaneous fat, which doesn't really seem like a secondary sex characteristic, except that it's mostly on the hips and the breasts, that subcutaneous fat accumulation. But it also is estrogen and progesterone play a role in widening of the pelvis. And it also makes it lighter in density. So estrogens and progesterone, though, they don't just do secondary sex characteristics. They do lots and lots of other things that aren't necessarily considered sex characteristics or secondary sex characteristics. And so that's why I'm showing you this slide.